Okay, so this is going to be 12.5. 12.5 is a little bit more difficult than 12.4. We are still finding volumes, but again, this is a formula that we are going to need to know. We are talking about pyramids and we're talking about cones. And the formula is the same for both, okay? But now we're still going to be dealing with the area of the base of our pyramid and the area of the base of our cone, and we're still going to be multiplying by the height of our pyramid and the height of our cone. But now we're going to just be putting a 1/3 in front of it, because basically what happens is, before when we did a prism, it was just base times height. What we're saying is a pyramid will always be 1/3 the volume of what an entire cube would be. Now, the one thing that we want to pay attention to is the h here is now going to be the height of the actual pyramid, meaning from the top of the pyramid down to the center of the middle. That's very important, not the slant height or that L that we were using when we found surface area, because now we're trying to find the amount that fills in on the inside. And the same thing is true about the cone. The height will be from the center of the cone down to the center of the radius, or where the circle is. Okay, so let's just go right into a couple of examples, because this is pretty much the same as what we were doing before. But there are things that make this a little bit more difficult. When we're dealing with a pyramid here, again, the idea is we know that our volume formula is 1/3 times big B times h. But we need to identify what our big B is. Remember, capital B means base. So what is the area of our base? So that's going to be a triangle, so it's 1/2 times base times height. Well, the problem is we don't know what the height of our triangle of the base is. We know what the height of the pyramid is. But remember, this bottom height is always going to be the height of the base. So like, in other words, we need to know what this is right here. Okay, just the base portion of it. So we have a problem here. It is a regular triangle, so we can set this up to be a equilateral triangle. So if I draw, the height that we want, so from this corner down here, I know that one side is going to be 4, and I know the other side is going to be 8. So I can use my Pythagorean theorem to solve for that missing height of the base. Remember, not the height of the pyramid, the height of the base. So we do 8 squared equals 4 squared plus, and let's call it h squared, because that's what the other side is. Okay, so what this looks like is 64 equals 16 plus h squared minus 16 from both sides. We have 48 equals h squared. Take the square root of both sides, just like a normal Pythagorean theorem, and we get that our h there is 6.93. Okay, so that means that the height of our triangle of the base is going to be 6.93. So now when I plug this in, my big B is going to be equal to 1/2 times base of the triangle, which is 8, times height of the base, or the triangle, which is 6.93. Okay? And that gives us 27.72. So that is the area of the base. Now we can just plug in everything else that we know for the volume. Volume will equal 1/3 times the area of the base, which is 27.72, times the height of the pyramid, which is 11. And that equals 101.64 feet cubed. So again, a little bit more work to do there, because we had to find out what the height of the base was, but it's still the same idea. Figure out what type of shape we have for the B, figure out what the formula to find that area is, and then plug in everything that you know. It's always easy to write out the formula and plug in everything that we know first. Keep in mind, the h on the big B will always be just the height of whatever base we're dealing with. The h on the actual volume is the height of the pyramid, or the height of the actual object we're dealing with there. Okay, let's look at this example here. Again, this one's not too difficult, but we're solving for something different. So it says the pyramid of the sun in Mexico is a regular square pyramid with a height of 63 meters and a volume. They're giving us the volume, but again, it's a pyramid. So we do volume is 1/3 times B times H. Well, what we need to decide here again is we don't know what B is. They don't give it to us. We want to solve for the side length of the base. Well, let's first decide what it is. So our base is a square. So that means our big B is going to be equal to sides squared. So what I'm going to do is instead of having my big B, I'm going to put S squared. So that means our volume is 1/3 times S squared times H. Now plug in everything that we know. We know the volume is 970,725 is equal to 1/3 times S squared, and we know what our H is. Our H is 63. So now we just go through and solve. Okay, we need to get S squared by itself. So I'm first going to, simplify this side. So it's 970,725 equals 1/3 times 63 is 21. So we have 21 S squared. Divide both sides by 21. And we get S squared equals 46,225. And then to solve for our side there, we take the square root of both sides, and we get S is equal to 215. And that's meters. Okay, so again, we set up the formula, write in what you know, and solve for what's missing. Okay, let's get to the cone, volume of the cone. This one should be fairly, not too bad here. So here we have an issue. So again, let's write out our formula. 1/3 big B H. Our big B in this case, because it's a cone, the base is a circle. That will be pi r squared. So let's write out what we know. Volume equals 1/3 times, okay, big B, well, let's plug this in, pi times, our radius here is not 3, it's 1.5, because it's half of the diameter. Okay, so we get our big B is going to be pi times 1.5 squared. So we'll get that in a minute. But the one thing that we're missing is the H. H is what we don't know. But we do know that we have a 5 here and we have a right triangle. So we really need to use the Pythagorean theorem again. 5 squared equals 1.5 squared plus H squared. Again, 1.5 because it's half right here. Okay, this is the missing side that we're looking for. And then we go to it. 25 equals 2.25 plus H squared. So then we're left with 22.75 equals H squared. Again, we minus 2.25 from both sides. Take the square root of both sides, and we get H equals 4.77. And now plug everything in. 1/3 times pi times 1.5 squared, that's our area of our base, times our height now, which is 4.77. Just plugging in what we know. 1/3 is good. Area of the base is pi r squared, that's this portion, and the height is what we found is 4.77, for a total of 11.24 inches to the third power. And that's it. Okay, next one. Again, we're looking for they're giving us the volume. Okay, so that's given to us. We are trying to find the radius. So again, let's write this out. Volume equals 1/3 big B times H. Let's write it out. Big B, we know big B is going to be a circle. So big B equals pi r squared. So let's write that in. Pi r squared times H. Now let's plug in what we know. 3.42 equals 1/3 times pi times r squared times H, and we know that our H is 2.7. So now we just start solving. Okay, so 1/3 of 2.7. Again, we can multiply this all out into a decimal. Okay, so we end up with 3.42 equals 2.83 r squared. Divide by 2.83. And we get r squared equals 1.21. Again, take the square root of both sides, and we get r equals 1.10. So some of these problems can be a little bit tricky, but again, write the formula out first, then plug in everything that you possibly know, and then we can go from there. So again, some of these may be tricky, and that's okay. Hopefully you just got a good introduction to how we're going to find the volumes of these things. So again, take your Edmodo quiz if that's been assigned, and I will see you in class.